High availability describes systems that are dependable enough to operate continuously without failing. This usually means that there are redundant components, like 2 or more devices, to enable this. The term availability is used to describe the period of time when a service is available and the ability of a user group to access a desired system or resource. Downtime is used to describe a period when a system or resource is unavailable. However, uptime and availability are not the same thing, as a system can be up but unavailable for other reasons. There may be a minute or so of downtime while one system switches over to another, but processing will continue. Now, there are several forms of high availability that we will address. Graceful restart. When the OSPF process on a device is reset, it drops all neighbor adjacencies, disrupting network operations while the other routers in the area have to rerun the Dijkstra SPF algorithm to find alternative paths through the network. With OSPF Graceful Restart, it allows you to restart the OSPF process on your router without dropping neighbor adjacencies. Your router will keep forwarding traffic while OSPF restarts and the network will not be interrupted. Graceful Routing Engine Switchover. This enables a router with redundant routing engines to continue forwarding packets even if one routing engine fails. Although this ensures that traffic is not interrupted, Graceful RE switchover does not preserve the control plane, so routing protocol information will be lost. Non-stop active routing. Used in conjunction with GRES, NSR also saves routing protocol information by running the routing protocol process on the backup routing engine. Both REs are fully active in processing protocol sessions, and so each can take over for the other. The switchover is transparent to neighbors. Bidirectional forwarding detection. BFD is a protocol that uses a simple hello mechanism with shorter time limits than default routing protocols, enabling it to detect link failures within milliseconds or even faster. A neighbor failure is detected when the routing device stops receiving a reply after a specified interval. BFD runs independent from any other routing protocols, and you can configure protocols like OSPF, BGP, VRRP, MPLS, LDP, etc. to use BFD for link failure detection instead of their own default processes. Virtual Router Redundancy Protocol, VRRP. Now, in our topology, there is one computer connected to a switch, which in turn connects to 2 routers. However, the client can only have one default gateway. Which one should it choose? VRRP enables a group of routers to form a single virtual router, and the client can then be configured with the virtual router as its default gateway. The virtual router uses the IP address of the physical interface of router A, which assumes the role of the master virtual router. If the master virtual router fails, the router configured with the highest priority becomes the master virtual router and provides an uninterrupted service for the LAN host. When router A recovers, it becomes the master virtual router again. Unified in-service software upgrade. ISSU allows you to upgrade between 2 different Junos OS releases with no disruption on the control plane and with minimal disruption of traffic. Unified ISSU is supported only on dual routing engine platforms. In addition, Graceful Routing Engine Switchover, GRES, and Non-Stop Active Routing, NSR, must be enabled. So the first of the labs that we're going to look at in regards to high availability is Graceful Restart. Now, Graceful Restart is going to be a good option if you've only got one routing engine, even though a lot of the Juniper MX platforms now have dual routing engines, so they would go for the option of GRES with non-stop active routing. But as we don't have that option of dual routing engines, Graceful Restart is going to be a good option for us. And this is the topology that we're going to be working with. So we have 3 routers. We have VMX R1, VMX R2, and VMX R3, and they're just configured in a line. And I already have the routers open. I've done the IP addressing, but I don't currently have any routing protocols or anything on there. So let's jump onto R1 and have a look. We should be able to ping R2, but we shouldn't be able to ping R3. So 1 ping 10.1.12.2, which is our directly connected interface to R2. But if I try to ping R3's interface, 23.2, we have no route. So what we first need to do, we need to enable our routing protocol. Graceful Restart could work on any routing protocol, but I'll be using OSPF. Edit protocols, OSPF. Set interface GE00.0. And I'm going to make all the interfaces point to point. I'm also going to reduce the hello interval so that the dead times are low. And this is just so we don't have to mess around with any DR, BDR stuff. Interface type is point to point. Hello interval is 1. Commit. Okay, let's do the same on R2. And we'll just leave them all in area 0. Interface type is point to point, and our hello interval is 1. The same for our GE001 interface. Let's commit that. And finally, we're going to do it on R3. Point to point. And R3 has a loopback interface with the IP address of 3.3.3 configured. And we'll set that as passive as we don't need to send any LSAs out of that interface. Okay, so now if we jump back over to R1, R1 should be able to ping via OSPF the 3.3.3 interface, which it can. And if I do a run show OSPF neighbor, we can see that we have a full adjacency with R2, and R2 will have a full adjacency with both R3 and R1. Excellent. All right, so most of the configuration, or all of our configuration, will be done on R3. So if I do a run show OSPF overview, we can see here that there are no graceful restart parameters configured at all. We don't see restart anywhere here in this configuration. So if I do a constant ping from R1 to R3, run ping 3.3.3.3 rapid, and let's just make it a count of 1,000,000. And we can see that that ping is continuing. We will see it jumping off the screen here. And if I was to run onto R3 and say something like run, what is it? Run, what is it? Run, restart routing. Yeah. If I restart the routing process, so this is emulating that the routing process on R3 has gone down. We see on R1 that we get a destination unreachable. Our routing has been interrupted. There's a no route to host. LSAs are being flooded all over the place while things are trying to reconverge, and then it reconverges and our neighbors come back up. But we've had a loss of service there where the routing process was restarted. So if I close that ping, and the reason that is that obviously the routing process was restarted, but graceful restart, basically R2 will help out R1 while the control plane restarts. The data plane will still keep processing and still keep forwarding packets. That's the theory anyway. So to enable that, there are two ways that we could do that. We could do that through the set routing options, graceful restart, and that will do a graceful restart for all routing protocols on the box, or we could actually just do it here under the OSPF process. If I say set graceful restart, maybe I need to not be under area 0, so let me say up, set graceful restart. And we've got some additional options at the end, like no strict LSA checking. We could extend the restart duration. I will do the no strict LSA checking, and all this is going to do, in my mind, is that if there's any changes elsewhere in the network, it can abort the graceful restart process. But we know there's not going to be any changes. But in a production network, we'd probably do no strict LSA checking. So I'll do that just for good practice. Let's commit that. Now if we run our ping from R1, I'm expecting no loss of packets when I say run restart routing. And okay, so there were loss of packets here. So our graceful restart did not work there. So let's try that again. Not under the OSPF process. Let me cancel that. Let me up arrow here. Let's delete this. Or maybe it's because it... I'm not sure. And let's try it under the routing options. So set routing options, graceful restart. Let me commit that. Oh yeah, let me commit that. Let's try again. Second time lucky. So we've got our ping running. Run restart routing. Okay, it works a lot better. I'm not sure why it didn't actually work under the OSPF process, but that's how graceful restart is supposed to work. You're not supposed to get any loss of service whatsoever. And let's check run show OSPF overview. And we can see here that we've got our restart has been enabled. This is what we're expecting to see if we have graceful restart enabled. And run show OSPF neighbor. Our OSPF neighborship is still up and we haven't lost any pings. Alright, that's it for this lab. Let's move on to the next one.